All right, so we are going to do a crash course in Polymer. So what are web components? Web components are a set of browser standards for web application development. So unlike if you've used Angular, if you've used Ember, if you've used Backbone, if you've used any of these sort of front-end libraries for building web applications in the browser, the difference between those and web components is that web components are actually a set of browser standards. That means that each of the browsers is implementing these natively. It's already landed in the latest version of Chrome, or at least major components of it have. I think Firefox has landed some of it, and it's on the track to be included in all major browsers. And in my opinion, web components are the most important browser technology for developers since the advent of Ajax. Once you sort of understand what web components are, what they can do, and how they affect sort of the landscape of application development, it's a sea change. And we're going to see web development 3 years from today is going to look pretty different from web development today in terms of the technologies that are being used on a daily basis, and that's because of web components. So web components recognize the browser as an application platform. So until now, the browser has been an application platform in spite of being designed as basically a document viewer. So that's obviously the original intention of hypertext. You have a document that links to other documents, and it was never really intended to be an application platform, but there happened to be JavaScript that allowed you to do these little dynamic things inside the browser, and people figured out that, hey, using JavaScript, using a dynamic server-side application platform, we can actually turn the browser into something that works as applications. And the reason that people wanted to do that is because the browser is the most ubiquitous platform that you can possibly deploy an application to. Everything runs a browser, everything from your phone to your tablet to your computer to ATMs to everything runs a browser. And because of that, basically web applications were born. So the web wasn't built for applications, but the web became an application platform. And what web components does is it says, hey, what if we actually built technologies for browsers that recognize that everyone uses the web as an application platform? And more even than just an application platform, browsers are basically an operating system. So one of the most interesting things that I realized, if you install Chrome on Windows 8 and you run it in sort of the Metro mode, I use a Chromebook as my primary computer, and the Metro version, or like the, new look, whatever they call it, version of Chrome in Windows 8 is Chrome OS. So they basically have a little Trojan horse where Chrome installed in Windows is just Chrome OS. You can install applications, it has its own little taskbar, and that's because the browser really does function as an operating system. It does all of the things that a typical operating system can do. It accesses the file system. It accesses devices that are connected to the computer. You can do networking with it. You can do all of these things. And it is truly cross-platform in a way that even something like Java isn't. So if you look at the browser as an application platform, and you look at the browser as an operating system, then how you build things on browsers and making that better and making that easier is one of the most important things that you can do. So why does web components being a standard matter? Why does being browser native matter? For one thing, performance. Once you have all of these things implemented natively in the browser, they're no longer relying on this JavaScript intermediary. You're no longer running code that then runs a whole bunch of JavaScript to do something to the DOM. Instead, the DOM itself is aware of this. The underlying C code, or whatever they're writing Chrome and Firefox and Safari in, the underlying code is aware of this stuff and does it natively. So web components are going to be very fast. Interoperability is something that is really huge, and I think is potentially the biggest impact that web components are going to have, because right now you have sort of this fractured ecosystem. You have jQuery plugins, you have AngularJS directives, you have Ember plugins, you have all of these different worlds that people live in. And each world is this sort of its own thing. They don't really interact with each other. But one of the most fascinating things about web components, because it's all based on this native browser technology, because it all has this common starting point, and that starting point is a standard, you can build native web components with different libraries, but they can still interact with each other. They can send events to each other using standard DOM events. You can use properties to access it. So Google has a library called Polymer, which is what I'm going to be talking about tonight. Mozilla has a library called Xtags. You can build Polymer elements that integrate just fine with Xtags elements. And so what that means is that we're looking at a future for the first time where the tools that you use to build your web application don't define the libraries that you can use to build it with. And that's a really big difference. And I think that that's going to be one of the biggest impacts. You also have less overhead. So because this is all native to the browser, you don't need 100K of library code just to bootstrap the bare minimum that you need for your web application. Instead, the browser actually gives you most of that for free. You can just have much smaller, much more focused libraries. Now, today, you still need to load polyfills for all of that, but we're talking, web components is a long-term thing. I'm not going to pretend that right now, every single person should drop everything they're doing and start shipping web components. We're kind of doing that, but that's because we're only targeting developers as an audience, and any developer who's not using Chrome or Firefox, I don't know what they're developing. So we're allowed to do that. You may not be, but this is how everyone is going to be doing it 2-3 years from now. And then the last thing is just flow. Everything, like I said, everything to this point, we've been fighting the browser to turn it into an application platform. This turns the browser into our ally, into our friend. Now we're going with the browser. We're saying, hey, browser, we're building an application, and the browser's like, cool. So there are 4 parts to web components. There's the shadow DOM, which is sort of one of the ones that gets the most attention. So the shadow DOM allows you to separate the presentation of elements in your source from the actual structure in the text file. So I could have an element that just is an empty div, but if I use JavaScript and I use the shadow DOM, I can actually create what's called a shadow tree inside that. And I can populate that with anything I want to populate it with. And then the browser will just swap that shadow DOM in when it displays it to the end user. So it's really the shadow DOM is the most mind-bending aspect of web components. It takes, that's the thing that you're gonna think about for a while, and it's not gonna make sense, and it's not gonna make sense, and then it eventually will. I don't know that I can necessarily make that process super fast, but basically what it means is that when you're accessing the DOM in JavaScript, when you're saying, document.querySelector and you want an element, you don't have to worry about it being cluttered up with a bunch of crap that JavaScript libraries have put in there because they need a special class called active or called library name -active-2 because of some weird manipulation and state that they need to keep track of. Instead, that all moves into the shadow DOM, and the actual content of the document stays really clean. The second part is the template tag, and the template tag is a really simple thing that basically anything inside the template tag is considered inert DOM. So it's HTML, but it's not HTML that's actually loaded into the context of the page. It's not HTML that's executed until you explicitly use JavaScript to clone that into the document, and then it becomes active. So what that lets you do, any of the templating languages you've ever used, handlebars, any of those, they're 100% JavaScript. They rely on you basically creating a big JavaScript string and then doing something with that string. What the template tag allows you to do is you actually have a template that doesn't display in the page, that just exists in the page, and you can access using JavaScript to do whatever you need to do with it. It's a really high-level thing, or it's a really simple thing that can then be used by libraries to do really complex things. The one that's the sort of the, if Shadow DOM and custom elements are sort of the headliners that get all the attention of web components. So custom elements lets you define your own HTML elements, and that basically is exactly what it means. Instead of having just div and span tags, you could have, user profile tag. You could have a, tab set tag. You could have custom tags that you build from the ground up that have all of the same functionality as first-class DOM elements. You can figure out when they've attached to the DOM. You can listen to events on them. You can set properties on them. You can do all of the things that you can do with native elements, except for you define the behavior that happens when you're interacting with them. And then the last part of web components are HTML imports. And that you can sort of think of as being script source for HTML. So it lets you point to another HTML file, and that HTML file can include custom element definitions, it could include its own script tags, it could include link tags to CSS, and it basically works like a module loader for HTML because script source only works with JavaScript, but link import, HTML imports works with HTML, so it implicitly works then also with CSS and JavaScript. Okay, so that's web components in a nutshell. Hopefully that was relatively coherent. Then there's Polymer, and Polymer, which is at polymerproject.org, is a set of polyfills for web components that Google has released, or at least that's the first thing that Polymer is. So Google is saying web components are the way forward, but we know that all browsers don't support it now. So Polymer is basically a way to say, here is a set of JavaScript polyfills that let you use web components even if a browser doesn't support it. And Polymer's goal is to be compatible with the latest 2 versions of evergreen browsers. So that means it's compatible with Chrome and Firefox and Opera for sure. It has compatibility with mobile Safari, with Chrome on Android, with, I believe it's IE 10 and 11, but 10 might have like a few caveats, so IE 11 and on I think are completely good. But the idea here is use web components today, the browsers will land all of this stuff natively tomorrow. Polymer is also a sort of sugar framework for defining elements. So a lot of the actual machinations of building something with web components revolves around defining custom elements. And Polymer gives you sort of a lightweight framework that makes it easier to define elements. So when we are coding today, we're going to be defining elements using the Polymer sugar. And basically, you can do everything that Polymer does without using Polymer, just using the browser native web components. But it sort of packages everything up nicely, and there's not a lot of reason not to use it. And then the last thing that Polymer offers is a set of custom elements that you can use to either build your own custom elements or just use directly in the page. And those are broken into 2 different things. There's the core elements, which offer sort of basic units of functionality. There's things like core Ajax, which allows you to make Ajax requests using an HTML element. There's things like core animated pages, which handles just sort of being able to animate between different transitions. So it's a lot of sort of utility functions and really basic things. There's also some UI components. There's core icon, which allows you to basically load in either PNG or SVG icon set and then display icons from that using a custom tag. So the core elements are sort of basic utility function or basic utility elements that you're going to compose together to build an application. The paper elements, if anyone was watching Google I/O, they talked a lot about material design, which is their sort of new design language and the new thing that they're sort of pressing going forward as a unified way to do things the Google way. And the paper elements are basically material design implemented for the web in web components. So basically it has it's a set of UI elements, it has buttons, text inputs, all of those kind of things, but it's all following material design principles. So when you click on a button, it has a nice little ripple effect that comes out from the button press and things like that. So it's implementing all of those material design aspects using Polymer, using web components. Okay, so that's what Polymer is. How do you use Polymer? So it's really simple. Basically, to use Polymer, you need Bower. You don't technically need Bower, but if you don't have Bower and you don't use Bower, you're going to have a bad time. So who is familiar with Bower, or who is not familiar with Bower, let me say? Okay, so we have some people. So Bower, which is the little bird icon on my Chromebook over there, is basically a front-end package manager. So it allows you to define the dependencies for your front-end application and download and install them to a directory on your computer. So if you've used a package manager for anything, if you've used Ruby Gems or NPM or NuGet, yeah. So any of the, it's a package manager, but for front-end stuff. And the Polymer team has sort of officially adopted Bower as the way to do this right now. And that's just because it makes things a lot simpler. I think that, I mean, I've talked to them because ideally they wouldn't be relying on a third-party library to have all of this browser native stuff going, and they recognize that, but there's sort of still some work to do there. So for now, Bower is the way to go. So I don't have it in here, but you need Node.js and NPM installed to be able to use Bower, and then you just do npm install -g Bower, and you're good to go. I believe it's bower.io. Oops. Yeah, so Bower.io will walk you through the whole thing. And I love Bower, regardless of Polymer, regardless of web components, I use Bower in every project I do. It just makes front-end dependencies actually manageable for the first time, which is really great. All right, so to make a bare bones app, I mean, the great thing about web components, you don't need a special runtime, you don't need anything. It's just a web page. You can even have it be a local web page with absolutely no no statics, no server running, no anything. So what you need to do, just make a directory. You need to install with Bower the Polymer/Polymer package, and then from there, basically, so here's the index.html that we'll have for this really simple app. So you can see we have, first we're importing from Bower the platform/platform.js, and that's the Polymer polyfills. So that's what lets you use web components even in browsers that don't support it yet. And then after that, we're using link rel import, which is how you do the HTML imports. And we're importing this custom component that I have defined on the next slide called hello world. And so then in the body, we just have this hello-world tag. And the only naming convention that is required as far as defining custom elements is that they have to have a dash in their name. And the reason that was done is sort of a very pragmatic decision. None of the native browser elements have a dash in their name. So by just saying all custom elements have to have a dash, you make it very clear, this is a default native browser element, this is a custom element. So sometimes you'll sort of pull out your hair because you're like, I can't think of a name with I can't think of two words to describe this. It's really just one word. But then you'll give up and you'll come up with something and it'll be fine. So here is the definition of our first custom element here. So the first thing that you'll need to do, you need to import Polymer itself. Oops, this is actually bad. So this should be link rel equals import href equals this. That's what I get for not reading over this before I presented. So you need to import Polymer, and that gives you the ability to use this Polymer element custom element, which is a custom element that allows you to define custom elements. We're going to get very meta here. So we're defining a custom element called hello world, and here we're indicating that we don't have any custom JavaScript for this element. We'll go through an element that both has JavaScript and doesn't as we go here. So first of all, we have the template, and so the template is where you're defining the shadow DOM for this element. So this is where you're defining, this is what the user, so in the document you have, if we go back, oops, go up, in the document you just have this hello-world element, and if you even open up the Chrome Web Inspector or the Firefox Inspector, when you're running the page, that's still all you're going to see. And that's really important because that means that this structure, it stays true from the source to running live. There's no manipulation, there's no adding classes, all of that stuff that I talked about as being an advantage of it being browser native. And so this template, all we're doing, and this is a nothing element, obviously, it's hello world. All we're doing is we have this style in here where we say host, and host is basically styling whatever the custom element itself is. And Jake's going to go a lot more into styling, so I'm not going to hit on that much. We're just saying make it red with a big font and sans serif. So what this page basically does is it says hello world in a big red sans serif font, which is, not exactly very exciting. So let's go on to something that's actually interesting. I was going to do live coding. I think I'm just going to sort of talk through the code instead, because I'm already I just think that that'll probably be better for this. So one thing that I want to plug real quick, because it's a DivShop project and we're proud of it, is ele.io. So that's ele for element. And basically, we've tried to create a JS fiddle for Polymer. So this lets you really quickly just jump in, play with a custom element, make a demo for it, and yeah, we've tried to make that really easy, because it's a little bit difficult to use some of the web component stuff in JS Fiddle or JS Bin or any of those existing sort of fiddle sites. So the first thing that we're going to look at is GitHub Readme. And so this is a custom element that fetches a README from a GitHub repo, renders the markdown, and then displays that as HTML in the page. And so looking here at the finished demo, there it is. So this is the code here, and I actually pointed this at the ele repository because ele's open source. So this right here is the README. If you go to github.com/ almost. So here's the README for the front end app that runs on ele, and here in our little demo, here's that same README rendered here. And the only code that's required to make that happen is this right here. Can everyone see that? Is that reasonably readable? I can try to make it a little bigger maybe. So here we have github-readme repo equals divshot/ele-web, and then we just close the tag. And that's all that's required. All of the AJAX fetching, all of everything is handled by the actual element itself. You don't have to do anything, you just include this in this code. So, one of the exciting things about web components is what you can build yourself with it. But another really exciting thing about it to me is what other people will build that you can then use with it. So if I'm GitHub and I have this API that's publicly accessible using CORS, which is cross-domain AJAX, I can create my own set of, GitHub could release an official set of GitHub elements that would let you really simply integrate any GitHub information. If you want to fetch information about a repository, if you want to, fetch information about a user, even if you want to do, even if you want to interact with that, they could release their own set of custom elements, and all you have to do is import those elements and use it just like this. So that becomes this sort of entire new powerful layer of web that we haven't had access to before. And Google is very keen on this. They're already working on, it's all very much in process in beta now, but they already have a Google Dash Map element, for example. So all you have to do is Google Dash Map, and then you put a location, and it renders a Google Map with everything there. And you can put, you can, inside that element, you can put, if you want pins dropped or whatever you want. So it creates this entire sort of customizable layer on top of the web. So, all right, so that's sort of the promise of it, but let's actually get into the nitty-gritty of how this is implemented. So whenever you're building a web component, you are going to put it in its own HTML file, basically. So this, if you were doing this in your own project, this would be github-readme.html. At the top of the file, you're going to want to import all of the other elements that you depend on. So in this case, we depend on Polymer and we depend on core AJAX. I've also got some documentation written here, because one of the fun things that ele does is it actually parses that documentation and then displays it, so you can sort of make your own element, and it's got documentation, and that's fun. Anyway, so we start with the Polymer-element definition. We have GitHub-Readme as the name, and then the attributes here are going to be the attributes of the element. So like repo is an attribute. And two attributes that you don't see are content and content HTML. So then we go into the template. And again, the template is how you're defining what the user is actually going to see. So this becomes the shadow DOM for your custom element. And there is, because we're using Polymer, we have this sort of mustache-like syntax where we can sub in values of attributes and things like that. That's not part of native web components. It is part of Polymer. It's really useful, so that's one of the reasons that I like building my web components with Polymer. So the first thing that we're doing here is we are doing a core Ajax element. And so what core Ajax does is it is just a custom element that makes an Ajax request. And so one of the interesting things about Polymer and about web components is that they don't have to just be visual elements. It doesn't have to be something that shows up to the end user in the page. It can be something that just manipulates data. You could have a local storage element that saves things to local storage. You could have any number of things that are just abstractions over data and processing, and then you can compose those together. So it's actually possible, like this has some JavaScript, but you can actually compose things without any JavaScript that will like make a request to an Ajax, then iterate through a bunch of JSON responses and render that out into a list. It gets really powerful once you start sort of fully tapping the potential of these custom elements. Okay, so the first thing that we do is we have a core Ajax. We have core Ajax for rec repo. So we have two requests here because I didn't even want to take the easy route and have it just have like a JavaScript markdown library that I'd use to render this. I'm actually using GitHub's Markdown API endpoint to render this into HTML. So first we have the repo fetching Ajax call. So you just set the URL, which can be either relative to the server or an absolute URL if it supports cores. So then we have response. So this is sort of an interesting thing that Polymer does. They allow you to bind values to attributes using this mustache syntax. So what I'm saying here is that I want to bind the value of the response attribute to the response property of my element. So let me see if I can actually open up Web Inspector here and do this for real. Okay, so we have the GitHub Readme element, and playing with like, oh, and actually here's a chance to demonstrate the GitHub Readme element, even though it has this whole Readme displayed, is still just a single element with no content in it, and that's just rendered as is because that's how web components work. And then if you turn on a setting, you can go into the shadow DOM, and this is where you actually see this content that we're defining over here in the template. And that's really tiny over there, isn't it? Okay, so we won't go in depth in this, but let me just say dot response. So if I say response, that is the JSON response that I was given here. So I can set a property of my element by binding it using this mustache syntax in Polymer, which is really handy because it lets me sort of store and manipulate data without having to dive all the way into JavaScript. The other thing that's really cool is that these properties are just properties on the element. So if you do in your document.querySelector GitHub Readme and you just have that node, you can access all of these properties. You can run all of these methods that we define down here directly on the element. So all of this sort of abstraction layer that you've always had to deal with in Backbone or Angular or whatever else you've been using, the abstraction is taken away and it just becomes that the DOM itself is sort of the engine of your application's state. And again, like a lot of these concepts, they're really hard to get all at once. Like I hope that some of this is making sense and some of it will just click over time, but sort of you'll have this epiphany moment where it's like the way that all this fits together really changes everything. Okay, so back to this. We store the response as the response property. We're handling this response as a JSON request, and then we have something that we do on error The little auto attribute here says we're going to automatically run this request whenever the URL changes. So that means that as soon as we get the repo attribute set, it's automatically going to trigger this response. And if you don't have that, then you have to trigger it manually with JavaScript. Okay, so then we have another core Ajax that does the markdown rendering. And notice this time the method is post. By default, the method is get. We change it to post here. And here we store the response as content HTML. And yeah, that's it. So this one is not automatically triggered because there was a little bit of special logic that we had to do. So then the only thing that we have left is we have this div where we're going to actually stick the rendered markdown content. So that's all there is to our Shadow DOM template. So let's dig in and look at the JavaScript that we wrote. So the structure of a Polymer element, you have Polymer element as the enclosing wrapper. Then you have a template tag, which defines your Shadow DOM. And then you have a script tag that defines any custom JavaScript behavior for the element. And if you don't want to have a script tag or you don't need a script tag, then that's when you add the no script up here in the Polymer element definition. Okay, so let's look at the script here. So first you just call Polymer as a function itself, and then you call that with the name of the element you're defining. And the reason you have to give it the name is because you can actually, this could be like a script source that references an external file and may define multiple elements or something like that. So you define the name of the element just so that it makes sure, yeah, we're all on the same page as to what we're talking about. Any properties that you set in this object that you're passing as the second argument here are the default values of that attribute for the element. So by default, the repo is just an empty string because it hasn't been set yet. By default, content is null, content HTML is null. And the Polymer team recommends that as much as possible, you hint the values of your attributes here. So if you have a Boolean value, you want to put true or false here because after that, Polymer knows to interpret that value as Boolean when it's set. And there are some advanced rules for sort of hinting things that you need to be set differently, but we're not going to get into that just yet. Okay, so another really, like, Polymer just does all these things where it's like, oh, that's really handy. And that's why I use Polymer, because it's all of these things that you could do on your own, but instead, oh, that's really handy, it's just built in for me. So one of the things that it does is if you define any function in this object that has the name of an attribute followed by changed, then that's going to fire whenever that attribute changes. So we have response changed, and that means that whenever this response attribute changes, then this function gets fired. So that's really handy. This in excuse me. This in any Polymer element function is always the element itself. So it is the instance of the node. It is the element. So what we do here is when we get a response back from the GitHub API, then we say, okay, we're going to set the content property to, this is actually base64 decoding the content because that's how the GitHub API returns it. And then we are saying that the body of the markdown request that we want to send is now set to the same content, because how the GitHub API works is you just post the markdown text that you want to parse and render, and it does that for you. And then we just say, hey, markdown request, let's go. Oh, another thing, this $$ allows you to access any elements with IDs in your Shadow DOM. So here we have, we're using this for rec markdown. So here you can see the ID is rec markdown. So in any of those functions, this $.rec markdown is going to refer to this core Ajax element. And one of the most important things about Shadow DOM that I didn't even touch on is that it's its own completely separate document, which means you can have it has its own unique IDs, so you don't have to worry about a name conflict. What if I have rec repo in my main document? What if I have multiple GitHub Readme elements in the same thing. Each shadow DOM is its own separate thing, so you can define the same ID in each of them, and that doesn't run into conflicts. So that's another important thing about the shadow DOM. Okay, so we do that, and then the response, as we saw up here, goes into content HTML. And then once we do that, all we do is set the inner HTML of this content div to the result. So, and that's pretty much it. Other than that, we display an error if there's an error, but that's how you fetch a README, render it with Markdown, and put it into an element using Polymer. Hopefully that sort of running through the definition of this helped. We're going to do one more, and this one I actually will code from scratch because it's much simpler and I don't have to remember as much. So this one is chat message. So that was like a fully, that fetched data, that had behavior, and that's one aspect of web components that's really exciting and really useful. But the other side, even just having the ability to define your own UI widgets is also really useful because it allows you, you've always been taught semantic HTML is good and you want to make your HTML as semantic as possible. Well, with custom elements, you can make your HTML very explicitly semantic. If you have a user profile, that could be an element that is user-profile. And so your HTML sort of takes on this whole other level. So what we're going to look at here is a chat message. So let's say that I'm building a chat program and I just want to be able to format the messages in a way that makes sense for my application. So if you look at the demo code here, you can see that I have the chat-message. I have chat-message, and then I define an author attribute. I define a time that the message was sent, and then inside the element, I just have the content of the message. And so then you can see how that turns out on the right. We have, an IRC-looking chat where it's, shows the username, and then it shows the message, and it's got the time code over here. That's Justin from MaxCDN, who I thought was going to be here tonight, but didn't end up being here. Yeah, and so then the other thing here, we have type equals action. And you can see that instead of having a colon here, it doesn't, and it has a blue background. So basically, without having to sort of have our own sort of semantics layered by class names, layered with a bunch of sort of weird HTML that we're putting together, instead we just have this nice, very readable, log of it looks like XML. If I were writing this. If I were writing this as XML, which I don't know if calling it like XML is going to get me friends or enemies here. Probably enemies. So forget that I said that. But regardless, this is extremely semantic because I am literally describing exactly what it is using this HTML. So the definition here is much simpler, and I will just try to recreate it very quickly. So, chat message. So I'm going to delete all this and hopefully be able to get back to it pretty quickly. So I start with my Polymer element, name equals chat message. I have, I have 3 attributes, author, type, and time. And I've specified no script because we're not writing any custom JavaScript here. So the first thing I'm going to do, and thank you very much for that water. The first thing that I'm going to do here is I'm just going to lay out our data. So let's just make this a few spans. We'll say span ID equals author, and that'll be the author. We'll have a span called the message. So if you want to display what is actually put inside of an element, then you need to use a special tag called contents. And what contents does is that takes the light DOM. So you have the shadow DOM, so that means that what you've always just called the DOM becomes the light DOM. So that takes the light DOM that is the children or the contents of your tag, and puts it into the shadow DOM at that location. So here I can say contents/contents, and now over here in a moment, you will hopefully see.
It's just content.
Oh, it's just content?
Yeah.
My bad, content. There it is. So now you see that the message appears over here. One of the things, do you remember what's the selector? Are you going into this?
I'm going to go into that.
Okay, forget that then. We're going to move on. Moving on. So now we have the time, and we put the time in here. And we're going to move the time up front. So one of the nice things is that you can make your shadow DOM as hideously ugly as you want. You can fill it with the most awful CSS hacks and HTML in the wrong order. Everything that you never want to do in the real world, you can do in the shadow DOM and not even feel that bad about it. So it's really nice. So I'm putting time first, even though I don't think I really would want semantically time to be first. And now I'm going to just add a couple basic styles, but not many because I'm going to let Jake mostly go into this. So we'll just say time, float, right, host, display, block. And the nice thing about using Ellie here is that you see all this happen as I do it, which I'm just going to keep plugging Ellie because I'm really proud of it. Okay, so, and then author, we'll do host type equals action background. What's a good color? How about CEF? Okay, so there we did some basic styling, and you can see now that, once I've imported this element, all I have to do, drop in a little bit of semantic HTML using my custom element, and it displays very beautifully. So that's sort of web components in a nutshell. Now Jake is going to go more into styling that, but before we go on, I think that was a whole lot of information, so are there any questions?
I have a question on, you were kind of saying that GitHub can kind of make its own little elements. Would that then be like a shareable widget that someone else could implement on their own site?
Yeah, absolutely. So basically how that would work. So
it's the ultimate like button.
Yeah, yes, exactly. So that is probably the most beautiful thing about web components is it takes all of these things that we're already doing, but doing in a really gross, ugly, or hacky way, and it says, no, we're going to make this really simple, really blessed and straightforward. So yeah, basically to use like a Facebook like button, all you might have to do is import or link rel equals import href equals facebook.com/like button.html, and then you just put that in your HTML and you're done. And the power of that, and the fact that people are already doing it so that things are drop in, but they're only drop in because that person has put an enormous amount of work on the back end to make it drop in. And so this is saying anyone can create these drop-in widgets, these drop-in data sources, these drop-in anything that you can do with HTML. And I don't even know what the landscape of development looks like once this is sort of fully propagated, once everyone knows how this works. It's a whole new ballgame. And yeah. So you just, like I said, I don't know what it looks like, but I'm really excited to get there. So yeah. Any other questions?
Well, yeah, you want to. I don't think you ever answered this question. I have so many questions about components. Who's the master? But how would you say it's any different than jQuery plugins?
Different than jQuery? Well,
how would you explain that?
How would I explain that?
Because I know you think it's better.
So again, I think it gets back to: are you building on top of an artificial construct that people built to get around browsers' limitations, or are you just building something in the browser? So the problem with a jQuery plugin is, what if I don't want to use jQuery? What if I'm using Angular instead? What if I'm using Moo or something else? I can't use any of those jQuery plugins that people have spent hundreds, thousands, millions of hours building because I don't use jQuery. But with web components, it's all browser native. Everyone's working from the same basic tool set. So everyone can use everything. I mean, not literally everyone can use everything, because you're going to see web components frameworks that sort of build their own ecosystem, but much more so than ever before, you have the ability to build small, isolated, completely contained units of functionality.
Also, jQuery doesn't have the cool sounding shadow DOM.
Anybody else?
I was going to throw out a Google I/O. One thing they did mention though, for now, is that like jQuery doesn't work great inside components.
Oh, is that
Yeah.
like being perfectly
you probably
honest?
don't need them.
Yeah.
Like you should. Like you may not need them, but that was one thing. People were like, can I use Angular inside my component? And they're like,
Yeah, so I mean, one of the things that is beautiful and terrible about working with web components is that you are working with like the bleeding edge future of web development, which means basically that any browser that doesn't support things like document.querySelector all and all of the things that we used to need jQuery for, any browser that doesn't support those is never going to support web components. So I look at web components as being a great time to make a clean break from the crutches of things like jQuery. And I mean, this is just my personal experience because I'm fortunate enough to be building things for developers, so I haven't had to worry about Internet Explorer at all for 3 years now. Like, I haven't used jQuery on a site in 2 years because I've been using Angular, I've been using native libraries, I've been using my own things. Now, that's not to say that there's anything wrong with using jQuery. It's a fantastic library for the things that it's needed for, but sort of the goal of web components is to narrow that list of things it's needed for to 0. So, yeah. Anybody else?
Are there any real-world examples off the top of your head that use Polymer now?
GitHub uses Polymer for these timestamps. So whenever you see the little timestamps here, that is just a
Can you cite that?
Yeah, or at least this is what I was told by the Polymer team. Time. It's just time, so maybe not.
There yet.
I know. I remember the Polymer team mentioning that timestamps in GitHub were Polymer. Ellie is itself entirely built using Polymer. That's in production, but obviously a very specific use case. It does work across mobile browsers, across Chrome and Firefox. Like, the case can be made for starting to roll this out into production in probably, now to the next 6 months. In a year, it'll be cut and dry. Like, everybody will support it enough to where you can just start doing it. Yeah.
When you say it doesn't really work nice with jQuery, and what about like other libraries like D3 and some like?
So, from what I understand, the reason it doesn't work nicely with jQuery is because jQuery is all about DOM manipulation, and because this is in the shadow DOM, jQuery doesn't really know what to do because jQuery has no concept of the shadow DOM. But as far as libraries like one of the very first web components that I wrote, just when I was, or actually it wasn't even a web component, I was just playing around with shadow DOM. I think it was HighCharts or one of those JavaScript graphing libraries, and I just made it so that it would turn an HTML table into a chart automatically without you having to do anything else extra to it. And so all those libraries like D3, anything, any modern library, most of them are going to work. And a lot of the elements that you see come out early, I think, are going to be people just porting various existing JavaScript libraries to web components in some form or another. So it's going to be hit and miss, but a lot of them are going to work, if that helps.
I think it seems to me probably the main issue between different libraries and stuff right now is it's scoping and stuff in the actual DOM.
Right.
Used to be more hacky. This is the whole thing, right?
Yeah.
And then now you get a richness of the shadow DOM, and I think other libraries there will be confusion in between those two. I think that's probably the thing with Angular still, right?
Yeah, I know that you can use Angular and Polymer together now. I think there's a few caveats on that. And I mean, basically, all of the major libraries are they're going to release versions that support these new standards because someone's going to submit a pull request or they'll do it themselves because they're just going to have to. Yeah. So, I mean, give it time, try out your favorite library. It's fully possible that you can like load a JavaScript library in the Shadow DOM and everything works fine, especially if it just attaches directly to an element. Like if it has some kind of like initializer function where you pass in a DOM node, that'll probably work perfectly. It's only things where it's sort of depending on like having the entire document when it's actually in the shadow or something like that. So
What kind of performance are you seeing? Like,
so
like with lots of elements. I guess what I'm wondering.
So I mean, this like Ellie is completely unoptimized. So this is actually Google released a library called Vulcanize that is sort of like a minifier for web components in that it takes all of these link rel import statements and concatenates them all into a single file. We tried that with Ellie, but we actually ran into a problem with the stable version of Chrome when we did that. So Ellie is actually loading like dozens of different HTML files, putting this all together, and I mean everything runs like pretty much 60 frames per second, because that was Google's entire mantra when they announced material design using web components at Google I/O. Like everything runs at 60 frames per second. So like I can't speak to specifically to like what if you have thousands and thousands and thousands, but like we built this with zero optimization and everything runs really smoothly. So
I mean, maybe the thing to do would be I could get on there and try the chat, put like 1,000 chat messages. 'Cause that's
yeah,
what I'm wondering if
here
people
let
get freaked out.
I'll see if anyone else has more questions, and I'll just start pasting until we run out.
Polymer website on my phone, and it was
So there's, yeah, like the loading right now I think is probably going to be the biggest problem, because if you're using a browser that doesn't support web components natively, then it has to load those polyfills, and those all have to execute and figure out what they're doing before anything can be displayed using web components. So like that's why like if you're shipping to production, like probably wait until at least one of the major like mobile browsers, ships it natively. But the delay is there, but it's not enormous, so it's sort of up to you to figure out what you want to do. Pasting. So, well, yeah, and the only reason it's not there sooner is because we have a debounce on this.
Yeah.
So here's like 300-ish, 240. So hopefully it's fast. We'll find out. Yeah, I'm going to let Jake do his thing. I had this on incognito, so you should be good to go.
Okay.